Hello, dear students. In this video, I will be explaining to you how to multiply and divide rational expressions, also how to find the non-permissible values. So stay tuned. So here is the first question for multiplying rational expressions. So this rational expressions here basically have a monomial over a monomial, and the same here, that's a monomial, that's a monomial. Monomial just means one term because you don't see any plus or minuses between here. So let's find the non-permissible values. So the non-permissible values, I'm just gonna call them NPM for non-permissible values. And here M cannot equal 0. And N cannot equal 0. So what's the non-permissible value? Non-permissible value is always the denominator of the fraction or the bottom of the fraction cannot equal 0, because we always remember that we cannot divide by 0. And the meaning of a fraction, it's top divided by bottom. That's what the fraction is. So we cannot have 0 on any of these bottoms right here. So if you see if we make this M 0, then this will be 3 times 0 times N, and that will go to 0. And that's why M cannot equal 0 for our non-permissible values. And also if we make N 0, this whole thing will be 0, and we cannot divide by 0. So that's why we call them non-permissible values. Yeah. We'll call them MPV. So a non-permissible value. And after this, now we're going to go ahead and solve this. So for me to solve this, what I'm going to do, I'm going to just cancel this N with this N. This M right here, I'm going to cancel, and the M squared becomes M. But also I have an M here, so I'm going to cancel this M and this M. Okay, so I get 1, 1 there. So what I have here, I have 2 over 3 times. At the same time, I'm going to distribute this exponent inside the brackets here. So remember, when you have an exponent outside the brackets, it gets multiplied into the exponents inside the brackets. Remember, the 6 has a 1, the M has a 1, and the N has a 1 on top of it that we don't write. Okay, so therefore this becomes 6 squared, M squared, N squared, all over 4N. And you know what? I forgot to reduce the 2 with the 4 here, but we could do that now. 2 goes into itself once, it goes into 4 twice. And this will give me 1 over 3 times, I'm going to square the 6, that's going to give me 36, and we still have M squared, N squared over N. Now I'm going to reduce everything that I could reduce. I'm sorry, there's a 2N here. So the 3 goes into itself once, it goes into 36 12 times, then the 2 goes into itself once and goes into 12 6 times. This N goes into itself once and goes into N squared N times. So my final answer here, you have 1 on the bottom, so you don't have to write that. And then I only have 6 M squared N. This 2 here belongs to there, just so that we don't confuse that. So 6 M squared N, that's what we have left on top. And this is the first question right here. Okay, so let's go to the second question. So for this question here, the first thing I'm going to do, because I see things that could factor, I'm going to factor first before I tell what my non-permissible values are. So I'm going to have 3b cubed, sorry, over, this is the difference of squares, and it's going to give me b minus 3, b plus 3 times, this here I could take out the greatest common factor, which is 2, and I'm going to get b minus 3 all over 2b squared. Okay, now let's talk about our non-permissible values for this question. So we have a b squared here. Of course, if we make this b 0, then we'll end up with 0 on the bottom, because 0 squared is 0 times 2 is 0. So b cannot equal 0. How about here? Whenever you factor, to figure out what makes, you have to figure out what makes every brackets here 0. So if you make b 3, 3 minus 3 is 0, times whatever that is, it's going to give me 0. So b cannot equal 3 either. And also, if you look at this brackets here, if you put a negative 3 for the b there, this whole thing will be 0. And then 0 times whatever that is, that's going to give me 0. So therefore, b cannot equal negative 3 either. Okay, now let's start reducing. This b minus 3 cancels with the b minus 3. This b squared cancels with the b cubed. B squared goes into itself once, goes into b cubed. B to the 1. Now, some students, they're tempted to cancel this b with this b. No, you cannot do that, because this b does not have plus 3 there, and this b is not free to be canceled because that's a binomial. This is a monomial. Again, if you want me to explain that to you, if you have 3 over 3 plus 6, if you cancel these 3's here, you'll end up with 1/6, which is wrong. And if you look at this would become 3/9, which will reduce to 1/3. So that's why you're not supposed to cancel this with this, because then you'll get a definitely wrong answer. Always bring it back to basics. When you're stuck in situations like this, bring it back to numbers, and see if that's possible to do or not. And from here, you cannot cancel the b's right there. So now, can we reduce anymore? We have a 2 here, as a matter of fact, and we have a 2 here, so they're going to cancel each other out. And then I still have a 3b on top. And I have a b plus 3 on the bottom. And that's as far as we could go. And this is the answer for this question. We'll go to the next one. So here, this question is division. So division is a little bit special, and I'll tell you why. So when you have this kind of situation right here, before we tell our non-permissible values, I'm just going to erase that from the last question. Before we tell what our non-permissible values are, what we have to do, we have to factor everything that's here. So we factor, this gives me m minus 1 times m minus 1, because when you factor, you're looking for two numbers that multiply to give you +1 and add to give you -2. -1 times -1 will give you +1, and -1 minus 1 will give you -2. And then this one here is the difference of two squares. So the difference of two squares, it just gives you m minus 1, m plus 1 when you factor it, divided by, this is again the difference of squares. So I'm going to have m minus 2, m plus 2. If you're having trouble with factoring, just go back to my videos about factoring, and I made that very clear in my other videos. Here, you're looking for two numbers that multiply to give you 2 and add to give you 3. So it's m plus 2 and m plus 1. Now I'm going to start telling what my non-permissible values are. So m cannot equal 1 and -1, because 1 makes this 0, -1 makes that 0. So plus or minus 1. Also from here, it's -2 and -1, but we already indicated the -1 there. But the thing, when you're dividing, always when you're dividing, you remember I said you always get your non-permissible values from the bottom or the denominators of the fraction. But when you're dividing, what you're dividing by, which is right here, you have to tell what the non-permissible values are from the top or the bottom and the top. So here, m cannot equal +2 and m cannot equal -2. We have the -2 there, but we didn't indicate the +2. So I'm just going to put the positive on top of that. All right. So these are my non-permissible values. Now you could ask me why, when you're dividing, you do that. Because when we were dividing, the next step we're going to do, I'm just going to cancel actually here m minus 1 with m minus 1 to make this life a bit easier. And you know what? I'm going to cancel this right here and right here. And I'm just going to go ahead now, and when we're dividing, we change it to multiplication and we flip. You remember? Keep, switch, flip. That's what we did. Now you could say, but why did you start reducing before flipping? Well, if I'm reducing within the same fraction, it doesn't matter. So here I didn't reduce m plus 2 with an m plus 2 here. That's not allowed when we're dividing yet, till we change it to multiplication. But within the same fraction, you could do so. To just this makes it look a lot easier. Okay. Now, anything else we could do from here? Yes, we could cancel the m plus 1 with the m plus 1. That gives me 1. That gives me 1. Now what I'm left off with is m minus 1 and m minus 2 on the bottom. Remember, you cannot cancel this m with this m, as I told you earlier. That's not allowed. Okay. You either have a whole binomial here is the same as this one, then you could cancel them, like m plus 1, you could cancel them. But here you cannot just say I'm going to cancel the m's and it equals -1 over -2, which is +half. That would be wrong. Okay, so let's go to the next question. So here's another question. It's division again. So my non-permissible values, I'm going to go ahead and tell what my non-permissible values are from here. You remember when we're dividing, we do it from the bottom and the top. So let's start off by saying m cannot equal -2, m cannot equal -5. Now I'm gonna flip this. Whatever you could do as early as possible, do it. Yeah, of course we need to factor this. Now I'm gonna factor this, and I'm gonna get x minus 5 x plus 2, because -5 times 2 gives gives you -10, and -5 plus 2 gives you -3. And here is the difference of squares. It's written kind of backwards. The variable is not for, didn't come first this time. It's the number that, or the constant that came first. Doesn't matter, because when we factor in the difference of squares, we put a minus and a plus, and then we go to the first thing, find out what the square root of that is, and it's 5. So I put a 5 here, a 5 there, and then the square root of x squared is x here, x there. Okay. Now I could cancel this x plus 5 with this x plus 5. I could cancel this x plus 2 with this x plus 2. This is x minus 5, and this is 5 minus x. If this is a plus, you could cancel them with no problems, because 3, let's say 3 plus 5 and 5 plus 3, they both give you 8 over 8, which gives you 1. Okay, but this is minus. Can we cancel them? You could cancel these with one condition. If you cancel them, make one of them equal -1. Why? Because let's go back to this and change it to -3 minus 5 over 5 minus 3. Now, if you look at it, 3 minus 5 gives you -2, and 5 minus 3 gives you +2. When you divide them, you get -1, and that's why you get that -1. And therefore, the final answer for this one is just -1. Okay, it's nice and simple. One more, and then we'll call it a day. All right. Hold on a second. I think I will miss some marks if I quit right here. See, maybe I did this ahead of the game, and then I listed my non-permissible values, and I thought it was over. Now it was not over, because I still have to list my non-permissible values from here. Well, the -5, x cannot equal -5 right here, because that would make 0, but we forgot about the x equals 5. So can I just put a plus right on top there? So m cannot equal, or x cannot equal plus or minus 5. I don't know why I have m there. This should be x, because the variable in there is x, which doesn't matter really, x, m, n, z. So x cannot equal -2, and x cannot equal plus or minus 5. Right. Let's go to the next question. So here's this last question. I'm gonna factor all over the place here. Everything is factoring about this one. So the top will factor into y plus 5, y minus 3. You might think, why is he factoring this so fast without having to think about it? Well, if you do this for long enough, you'll be able to do the same thing. Okay. 5 times -3 is -15. 5 minus 3 gives me +2. And here, y minus 7, y minus 1 times y minus 7, y plus 2, all over y plus 5, y plus 2. All right. Now, non-permissible values, y cannot equal 1, 7, -5, and -2. So 7 makes this 0, 1 makes this 0, -5 makes this 0, and -2 makes that 0. So it's not dividing here where we have to do top and bottom. You just do bottoms when you're multiplying. Okay, and now you could just start reducing. This y minus 7 will take this y minus 7 away. This y plus 5 will take this y plus 5 away. Y plus 2 from here takes away y plus 2 from here. And my final answer is y minus 3, y minus 1. And this is it for this lesson. If you found this video helpful, please like, share with others who will benefit, and subscribe to the channel. Your support goes a long way. Math videos uploaded every week. Check out our videos and browse our playlists for more helpful math videos. As always, thanks for watching. Till next time.